Here they have given us equation and they are asking about the roots of that equation. First option says that no real root, second option only one real root, third it has two real root, fourth option says that more than two real roots. So how to tackle this kind of problem? Look at your equation is, this is your equation, and simply denote this part as fx. So your fx is going to be this is your fx. Fine. Now just for your further calculation purpose, you just take 19 to the power x common and you will have this kind of stuff. Here hand. Okay, these two steps you have to do. After that, simply find what is the sign of f of 0 and what is the sign of f of infinity. To find f of 0, immediately you can take this or that expression and it will be clear to you that f of 0 turns out to be plus 2. That means it is a positive quantity. Okay, so sign of f of 0, it is a positive, and f of infinity, for f of infinity just take this second expression here 19 to the power infinity, and rest of this three term will contribute 0 and here it is minus 1. So you have negative infinity as your f of infinity or something negative. Okay, fine. So you have, suppose this is your x is equal to 0 say, and f of 0, that means somewhere say any positive value. Suppose this is your f of 0, the positive quantity, and f of infinity, here the very last part of this x axis you have f of infinity which is standing here. That means some negative quantity which is f of infinity. Fine. That means the graph of fx, graph of this fx has to cut this x axis at least once, because fx is a continuous curve, so it has to cut the x axis at least once. That means it may be like this way, it may be like this way, or it may be like this way. In that case it has multiple roots. So what you can conclude is this fx has at least one real root, because the graph will cut the x axis at least once. Clear? From that point of view, you can say first option is wrong, because first option says that no real root, but it is guaranteed that you have at least one real root. Clear? Now the question is whether this function fx has more than one real root or not. For that purpose, simply we are taking, if possible, let fx has two real roots, say alpha and beta. These are two real roots. Okay, that means f of alpha is equal to 0 and f of beta is equal to 0. Even your fx is continuous function and there is no problem with the differentiability as well in the interval 0 infinity, and moreover you have f of alpha is equal to f of beta. So all these conditions are leading to Rolle's theorem, which says that if all these conditions are satisfied, then you have some c in the interval alpha beta. There exists at least one c such that f dash c is equal to 0. That means the derivative of your fx is going to be equal with 0 at some c. Clear? So your next job is to verify whether this thing is holding or not. Your fx is 11 to the power x plus 13 to the power x plus 17 to the power x minus 19 to the power x. Fine. Now simply perform the derivative and you have this kind of thing. Log 17 minus 19 to the power x log 19. And it is immediately clear that for any finite value or even infinite value, you can say for any values of x, f dash x, it is never going to be equal with 0. Means it is not equal to 0. But your condition, all this condition leads to f dash c is equal to 0. So it is a contradiction. Clear? That means your assumption, starting assumption was wrong. And what you have assumed? You have assumed that fx has two real roots. In fact, it has more than one real root, and you are assuming that fx has exactly two real root. So it is not possible. Clear? That means fx has exactly two real roots, which is in the third option. It is false. Okay, and that implies fourth option is also your false option, because fourth option is saying that more than two real root, but it is never possible. Similar kind of approach, you can discard your fourth option as well. So first, third and fourth, these are your false options, and remaining option, the second option, is the correct one. It means it has only one real root. Okay.